Okay, good evening. Welcome to
FamilyMath number 874.
Math874. So this is something I saw from our friend Leo Stein. He shared it last night. It's a binary black hole explorer. Do you know what black holes are?
Yeah.
All right, tell me what they are.
They're objects that are so dense that they suck in everything, and not even light can escape them.
Okay. Have you ever heard of binary black holes?
No, but I assume there's two black holes close to each other.
Okay. Yeah, so they have a that's a pretty good observation of what it is. Have you ever heard of gravity waves?
I've heard about them. I don't know about them.
Okay, so yeah, two black holes spinning around each other emit these gravity waves that were detected on Earth last year for the first time, and that was actually the reason for the Nobel Prize in Physics. So here's what it looks like.
A larger one and a smaller one.
Yeah, I guess in this case, they can vary the sizes, presumably. So what do you see here? What do you think's going on?
So the gravitational pull of each black hole is making the other rotate. I guess slight deviations are throwing the orbits around.
What do you mean by that?
Like, that's why it's kind of turning right now. And then I guess rotation seems to be slowing down. They're getting close to each other.
Yeah, they always pause the video at this point and then watch what happens.
And closer, and then they merge. And then it stables out, and then moves away.
It sort of floats away. So one thing I wanted to ask you is, what do you think the math is? Because Leo said in one of his tweets last night that they used to need a supercomputer to do all these calculations, and they wrote a neat program in Python where we can run these on our laptop if we wanted to. So what do you think some of the math involved is in studying these black holes and what they're doing?
You probably need to know, I guess, like elliptical motion pretty well.
Yeah, I bet you do need to know elliptical motion pretty well.
And like, I guess how mass influences, like mass and gravity are related.
Yeah, that's more physics though, it's definitely very important. But that's not the math as much as the physics. I was more interested in what sorts of math ideas you think go into making these sort of...
Probably at least some calculus.
Yeah, where do you think the calculus would come in? Like, where do you think you need calculus?
I guess for showing the change in the orbits, kind of like what's happening here.
Yeah, that you definitely do. You need to have calculus and definitely differential equations they have to solve. So they have a long list of visualizations here. Hopefully it shows up on the screen. But do you see any... why don't you pick two that we can take a look at, and then you can tell me what you see.
Let's look at how the aligned spin binary black hole.
Okay, it's funny. Your brother picked that one too. And then any other one you see?
How about the sinusoidal kicks?
Okay, so aligned spin. So, did I pass it already? Oh no, here it is. Aligned spin. So, yeah.
Is this spinning in the same way?
No, it's a different... You see how the arrow and the small one's pointing up?
Yeah.
And the red arrow is pointing up, so that's... the spin relates to something in physics called angular momentum. So the one black hole there is arrows pointing up, and the whole system's arrows pointing up. So do you notice what's happening here? What's different on this one?
So the orbits aren't rotating around.
Yeah.
Although they are still going smaller and smaller.
That's right. So they're not tilting like they were before in this one. And then the black hole shoots off in some direction. And then you wanted to see the sinusoidal one? Let's see what that is. Sinusoidal kicks. Oh, actually, I've never even watched this one. All right, what's happening here?
So it looks like these are ones where the two black holes are on the same orbit.
Oh, interesting.
It looks like, I guess, the different methods of where the arrows are pointing, which, yeah.
Okay, yeah, the kick velocity is very sensitive to the orientation of the component spins near merger. Here we show several cases that have equal mass. Okay, interesting. So yeah, you're right. You notice that the arrows were all aligned differently, and so it's gonna be interesting to see where the black hole, the merged black hole, moves away. It should be all different for each of them. Let's see. Yeah. Huh. That's pretty neat.
Yeah.
So so I guess this simulation probably allows them to get a pretty good idea from the gravity waves they detect, which are these waves. They detect those on Earth. Probably gives them a little way just to see into those waves. What do those waves remind you of? What do you think the math is in those?
Probably trig, look like sine, cosine waves.
Yeah. So you can study those waves, and then if you have a good model that shows here's what's happening that produces this wave, you can match the waves to the model and maybe get some insight into what's going on. This is pretty neat. Is this something you'd like to learn more about?
Yeah.
Yeah. All right. Well, we might have to ask Leo some questions. All right. Good job, man.